All right, let's solve the first example from chapter 8. In this example, we are going to practice the right-hand rule. So it is question 163. Let's read the question. What is the direction of the magnetic force on a positive charge that moves as shown in each of the 6 cases to your left? We are going to consider each cases one by one. For this example, I highly suggest that you look at the diagram at the same time. I wrote a version on the board, but it's easier with the diagram in your note. All right. One thing I want to talk about, we are going to be considering a positive charge. If we were to consider negative charge, the direction of the force will be 180 degrees out of phase. It will simply be pointing in the opposite direction. All right. So let's consider part A. In part A, we are given the velocity vector is pointing down, and we have the magnetic field pointing out. What we need to do is we point our finger toward the velocity vector down. We curl a finger toward the magnetic field. The magnetic field is pointing out, so my fingers are pointing out now. And the thumb is pointing in the direction of the force. For A, the force is pointing to the left. So here, left. All right. So part B, we do exactly the same logic. Point toward the velocity. In this case, we need to curl toward the magnetic field, and my thumb is pointing into the board. So the force is into the page here, or into the board in my case. All right, part C. So part C, we have the velocity vector to the right, magnetic field into the board. So we're curling our finger into the board, and my thumb is pointing up. Part D, we start with the velocity pointing to the right, but there's a catch here. If we look, we need to curl our finger in such a way that we cover the shortest angle possible. We could go that way, so pointing my finger inward, or I could literally go outward, and that will still work because in both cases the angle will be 180 degrees. However, if you recall from the formula, the magnetic of the magnitude of the magnetic force, we need to use a sine of the angle. Well, the angle between the velocity and the magnetic field here is 180 degrees. Sine 180 degrees is 0. So here it is 0. There's no magnetic force over here because they are 180 degrees apart. We also will get a 0 if the angle between them were 0. So if the velocity vector were pointing exactly in the same direction as our magnetic field. All right. Let's go to E. So in the case of E, we got the velocity is pointing in, so we point a finger inward. We curl toward the magnetic field, so upward. So in this case, it's to the right. Last one. Point the velocity out, so toward you. Curl the finger toward the magnetic field, and my thumb is pointing down. All right, so in the next question, well, I'm not gonna solve that one, but you will need to work on question 164. In question 164, we're considering a negative charge. So when we're considering a negative charge, it's simply the opposite direction, okay? So keep that in mind. All right, so we are going to be solving many other examples in this chapter. So let's move on to some other example.